Hello, welcome to our first class for plane and spherical trigonometry, week 1. Our topic for this week is trigonometric functions of acute angles. Our course outcome for this week is CO1, solve problems related to plane right triangles. And our learning outcomes for this week are LO 1.1 and 1.2, which are discuss the trigonometric functions as solutions to plane right triangles and discuss the fundamental trigonometric identities. Now you might ask, what is trigonometry? Trigonometry is the branch of mathematics concerned with the measurements of the parts, sides, and the angles of a triangle. In this course, we are going to cover plane trigonometry and spherical trigonometry. Plane trigonometry is restricted to triangles lying in a plane. It is flat, it is not curved, it is not spherical. And spherical trigonometry is restricted to triangles that lie on a sphere. Trigonometry is based on certain ratios called trigonometric functions. The early applications of trigonometric functions were to surveying, navigation, and engineering. These functions also play an important role in the study of all sorts of vibratory phenomena such as sound, light, and electricity, and many more. In this lesson, we will discuss trigonometric functions as solutions to plane right triangles and the fundamental trigonometric identities. Now, a lot of students ask this question: why do we need to study trigonometry? Is it really important when we are already working on board? Do we really need to use sine and cosine? Well, yes, historically, trigonometry has been used for locating latitudes and longitudes of sailing vessels. It is also used in plotting courses and calculating distances during navigation. Trigonometry is still used in navigation through such means as the GPS or Global Positioning System and AI or Artificial Intelligence for autonomous vehicles. In your study of marine transportation, you're going to encounter a lot of topics that directly use or directly involve trigonometry. This include but are not limited to course, bearing, true course, compass bearing, true bearing, relative bearing, simultaneous bearing, line of sight, angle of elevation, latitude, longitude, small circle, great circle, rhomb line, Mercator chart, mnemonic chart, ship stability, angle of list, angle of heel, angle of lull, rolling angle, angle of repose, drift angle, right angle emergency maneuver, altitude angle, azimuth angle, sextant angle, zenith distance, polar distance, colatitude, and a lot of many other topics involve trigonometry. Let's start our discussion on trigonometric functions of an acute angle. This is a right triangle. Why is it a right triangle? Because it includes an internal angle which has a measure of 90 degrees. So in this triangle, angle C has a measure of 90 degrees, and it is a triangle. Therefore, this triangle is a right triangle. In dealing with any right triangle, it will be convenient to denote the vertices or the pointed corners or pointed parts. Those are the vertices. You denote them or you name them with capital letter A, B, and C. Actually, you can use any letter as long as you are consistent. And you denote the sides or the length of the sides as small letter A, B, and C. So as you can see, angle C is measured 90 degrees, and opposite to that is small letter C, and that is called the hypotenuse. The hypotenuse is always opposite to wherever the 90-degree angle in a right triangle is. It is opposite, or it's on the other side. With respect to angle A, so if your point of view or your perspective is in angle A, small letter A will be called the opposite side. C is still the hypotenuse, and side B is the adjacent side to internal angle A. With respect to angle B, if you are looking through angle B, side C is still the hypotenuse. Side B is now the opposite because it is right across angle B. And side A is beside angle B, so that's the adjacent side. Measures of angles. Usually, angles are measured in these common units of measurement. The first unit is revolution. This you can usually encounter revolution when measuring for RPM or revolutions per minute. It is the unit of how many times a certain object rotates or revolves around its axis. Usually you encounter this in the revolution of the shaft of the internal combustion engines, the cylinders, the propellers. So these are commonly measured in RPM. So one complete revolution or rotation with respect to its axis is measured in revolutions. The next measurement is degree. In navigation, this is the unit of measurement used. If you divide one revolution or one complete circle into 360 parts, one part of that is 1 degree. So a complete circle is 360 degrees. The SI, for instance, this is a 45-degree angle. This is a 90-degree angle. This is a 180-degree angle. This is a 270-degree angle. And a full circle or a complete rotation or revolution is a 360-degree angle. It can go beyond 360 degrees. For example, if you rotate or revolve twice, that would be 720 degrees. The SI unit of angular measure is the radian. This is an example of a pi over 4 radian. This is an example of a pi over 2 radians, or 1/2 pi. This is an example of a pi radian. This angle is measured as 3 pi over 2, or 3/2 pi radians. And a full circle is 2 pi. Take note that pi approximately is 3.14, so 2 pi is 2 times 3.14, that's 6.28. So 1 full circle is approximately 6.28 radians. Another unit of measurement for angle, but not really very common in onboard applications, is the grad. A full circle has 400 grads. And another unit of measurement for angles is mil. One full circle has a measure of 6,400 mils. What are trigonometric functions? If now the right triangle is placed in a coordinate system so that angle A is in standard position, so it's at 0, 0 of this coordinate system, and the point B on the terminal side of angle A has coordinates BA, and the distance C is equal to the square root of a squared plus b squared. Then the trigonometric functions of angle A may be defined in terms of the sides of the right triangle as follows. Sine A, or sine of angle A, is equal to the ratio of side A to side C, or the opposite side to the hypotenuse. Cosine of angle A is equal to side B divided by side C, or the ratio of the adjacent side to the hypotenuse. Tangent of angle A is equal to the ratio of side A to side B, or that's equal to the ratio of the opposite side to the adjacent side. Cotangent A, or the cotangent of angle A, is equal to the ratio of side B to side A, or equal to the ratio of the adjacent side to the opposite side. The secant of angle A is equal to the ratio of side C to side B, or that's the ratio of the hypotenuse to the adjacent side. And lastly, the cosecant of angle A is equal to the ratio of side C to side A, or that is equal to the hypotenuse divided by the opposite side. Now these 6 trigonometric functions they have complementary angles. The sine of angle B is equal to the cosine of angle A. So let's see where that's located in our illustration. So sine B is just equal to the cosine of angle A. So that means if you try solving in your calculator sine B, and then you solve cosine A, they will have the same answer because they are complementary angles and they are equal. So the remaining angles, cosine of angle B is equal to the sine of angle A, tangent of angle B is equal to the cotangent of angle A, cotangent of angle B is equal to the tangent of angle A, secant of angle B is equal to the cosecant of angle A, and the cosecant of angle B is equal to the secant of angle A. What are trigonometric identities? In mathematics, trigonometric identities are equalities that involve trigonometric functions and are true for every value of the occurring variables where both sides of the equality are defined. Geometrically, these are identities involving certain functions of one or more angles. They are distinct from triangle identities, which are identities potentially involving angles but also involving side lengths and other lengths of a triangle. These are the basic trigonometric identities. On the first column are the reciprocal relationships of trigonometric functions. The cosecant function of an angle is equal to 1 divided by the sine of that same angle. The secant of an angle is equal to 1 over cosine of that angle, and the cotangent of an angle is equal to 1 divided by the tangent of that angle. On the second column are the quotient relationships. The tangent of an angle is equal to the sine of that angle divided by the cosine of that angle. And the cotangent of an angle is equal to the cosine of an angle divided by the sine of an angle. And on the third column are the Pythagorean relationships. The sine of an angle squared, or the sine squared of an angle, plus the cosine squared of an angle is equal to 1. 1 plus tangent squared of an angle is equal to the secant squared of an angle. And 1 plus cotangent squared of an angle is equal to the cosecant squared of an angle. In problem solving, how do you select which trigonometric function to use? So these are the guidelines in finding a side of a right triangle. When an angle and one side are known, there are two trigonometric functions which can be used: a function and its reciprocal. When manually solving the problem, the choice is usually made so that the unknown side is in the numerator of the fraction. This is done so that the operation needed to solve the equation will be multiplication rather than division. Much easier. When a calculator is used, the function selected is either sine, cosine, or tangent, because those are the functions that are represented by the keys on the calculator. So in deciding whether to use sine, cosine, tangent, cotangent, secant, and cosecant, you just try to analyze what are the known parts, what are the known angles, the given sides. Is it the opposite side, the hypotenuse? Is it the adjacent side? And with that, you try to select from the 6 trigonometric functions which is applicable. Which one is applicable to your problem? Now, let us differentiate angle of depression from angle of elevation. Angle of depression is the angle from the horizontal down to the line of sight from the observer to an object below. So as you can see in the illustration, if this is the observer, this is the horizontal, and this is the line of sight. The observer is looking at the object, so the line of sight is downwards. So the measure of the angle from the horizontal to the line of sight is called the angle of depression. Now, what is an angle of elevation? The angle of elevation is the angle from the horizontal up to the line of sight from the observer to an object above. So as you can see in this illustration, the observer is looking at an object above. So he's looking up. This is the line of sight. This is the horizontal. The angle between those two lines is called the angle of elevation. Now let's try to solve this example problem, and let's apply what you have learned so far. From the top of a lighthouse 175 feet above the water, the angle of depression of a boat heading towards it is 18 degrees 50 minutes. Calculate the speed of the boat in knots. If, after it turns and heads perpendicular to its initial course for 2 minutes, the angle of depression is 14 degrees and 20 minutes. The first step is you should draw a diagram that represents the scenario of the problem. So let's draw the sea. Let's draw the shoreline, and there's a lighthouse. Now the measure of the top of the lighthouse from sea level is 175 feet. That's the measure from sea level to the top of the lighthouse. Now there is a boat heading towards the lighthouse. Initially, it has an angle of depression of 18 degrees and 50 minutes. Take note that 1 degree has 60 minutes. So 18 degrees 50 minutes is almost 90 degrees. Then the boat turns and heads perpendicular to its initial course. So let's try to draw its initial course. The initial course of the boat is headed towards the lighthouse. Then it turns perpendicular. When you say perpendicular, it forms a right angle or 90 degrees from its original course. So it's not indicated in the problem whether it turned port side or starboard side. So you can assume either way. So the boat turns perpendicular to its initial course, and it travels for 2 minutes. So after 2 minutes, we can say that the boat is around in this area. With the boat in that area, it has a new angle of depression from the top of the lighthouse, which is 14 degrees 20 minutes. So how do we, this is a better version of the drawing. How did we get 14 degrees 20 minutes and 18 degrees 50 minutes on the bottom when it was given at the top? Well, you simply applied geometry, because as you can see, the horizontal to the angle of depression is parallel to the seawater or sea level. Thus, you can deduce that this angle is 18 degrees 50 minutes. That's for this right triangle. And for the second right triangle, this angle is 14 degrees 20 minutes, which is what is shown in this illustration. Now, that's the first step. We have successfully drawn the problem. Next step, step 2. Now let us solve for the measures of the relevant parts of the three triangles formed in the diagram. Can you see the three triangles formed? The first triangle is this one. The second triangle is this one. And the third triangle is flat on the surface of the water. They are all right triangles because they include 90 degrees. Let's start with the first triangle, the green triangle. For the green triangle, there is a given internal angle of 18 degrees 50 minutes and a side opposite to that, which is 175 feet in length. So we have an angle C, as notated in the drawing, and an opposite side, which is 175 feet in length. So which of the 6 trigonometric functions can you use if you are given an angle and an opposite side? What are we looking for? If we are looking for the hypotenuse, we can use sine, and if we are looking for the adjacent side, we can use tangent. Since we are looking for the adjacent side, this line from point C to point A, we will use tangent. So tangent of C is equal to the opposite side over the adjacent side, where the opposite side is 175 feet, and the angle C is equal to 18 degrees and 50 minutes. So how to solve for adjacent? First, you transpose adjacent to the numerator of the term in the opposite side of the equality, and you transpose tangent 18 degrees in the denominator of the term opposite to the equality. So in short, you have adjacent side is equal to 175 divided by tangent 18 degrees 50 minutes. So if you solve that in your calculator, you will get 513.08048 feet. Or initially, the boat, before it made the turn, initially it is 513 feet away from the lighthouse. Let's do the same for the orange triangle or the second triangle. Remember that the boat made its turn perpendicular to its initial course, and after 2 minutes it reached point B. Initially from point C, after 2 minutes it reached point B. Let's try to solve the triangle in point B. Since we are also trying to solve the adjacent side, and we are given the angle and an opposite side similar to our first solution or our first triangle, so we can solve using the same process. Tangent of 14 degrees and 20 minutes is equal to 175 feet over adjacent side. You transpose adjacent and the tangent of the angle if you try to solve it in your calculator, 175 divided by tangent 14 degrees 20 minutes, your answer would be 684.88735 feet. 684 feet. So that means that when the ship reaches point B, it is now 684 feet away from the lighthouse. Lastly, we will solve the third triangle or the blue triangle. In order to solve for the distance between position C and position B, we are given two sides of the triangle, which is 684 feet and 513 feet. We will use the Pythagorean theorem to solve for the remaining side. Pythagorean theorem states that the hypotenuse is equal to, or the square of the hypotenuse is equal to the sum of the square of the two other sides. Remember that the hypotenuse is opposite to the 90-degree angle. In the blue triangle, our 90-degree angle is right here at position C. Therefore, the side opposite to it is the hypotenuse, and the side opposite to it has a measure of 684 feet. So that's our hypotenuse, 684 feet. And one side is equal to 513 feet. To solve for B, we need to transpose 513 squared to the other side of the equality. So using the rules of equality, that would be 384 squared minus, take note that's minus 513 feet squared. That's equal to B squared. To get B, you try to square the answer of 684 squared minus 513 squared. You try to get the square root of that. So the final answer, B, is equal to 453 feet. 453.6729 feet. 453. Now we have a measure of this distance, the distance that the boat traveled within 2 minutes. Let's not get confused with the unit of time, minutes, and the unit of angle, minutes. Those are different minutes. In that unit of time, minutes, so this is basically a unit of time, and the angle is a unit of an angle. 14 degrees 20 minutes and 18 degrees 50 minutes. Those are not the same unit of measurement. They just have the same name, so don't get confused with that. Lastly, we need to solve the speed of the boat. The formula for speed is distance over time, the distance traveled over a period of time. So as we have solved, the distance traveled by the boat is 453 feet, and the time is 2 minutes. Since it's asking for the answer to be in knots or nautical miles per hour, we need to multiply for the unit conversions. So in 1 meter, there is 3.28084 feet, and in 1 nautical mile there's 1852 meters, and in 1 hour we have 60 minutes 60 minutes in 1 hour. We chose this unit conversions because we need a unit of knots, which is nautical miles per hour. So we need to convert feet into nautical miles and minutes into hours. Our first conversion is converting feet to meters, so the units will be cancelled out. And next we need to convert meters to nautical miles, so the units will be cancelled out. And lastly, we converted minutes to hours, so what remains is nautical miles and hour. So you just simply multiply 453 times 1 times 1 times 1 times 1 times 60 divided by 2 times 3.28084 times 1852 times 1, and that is equal to our final answer. The speed of the boat is equal to approximately equal to 2.24 knots, or approximately equal to 2 knots. That's the speed of the boat, and that's our final answer. The speed of the boat from point B to point C is approximately 2 knots. For your exercise, try answering this problem on your own so you can apply what you have learned so far. The question is, from a stationary ship at sea, the angles of elevation of the top and bottom of a lighthouse situated on the top of a hill at the coast are measured as 47 degrees 54 minutes and 39 degrees 45 minutes respectively. Find the height of the hill in meters from sea level if the height of the lighthouse is 115.5 feet. So take a shot of that problem and write it in your notes. Our evaluation for this week is, at the end of this week, you should be able to discuss trigonometric functions as solutions to plane right triangles. Go to week 1 classwork posted in the online classroom for NGEC 9, plane and spherical trigonometry, for the details of this assessment. Thank you very much. And next week we will be discussing about special triangles.